fourth day of the session organized by Hex-Star Universe in collaboration with SA, Citizen Science Group, and Life to Beyond Earth Foundation. Life to Earth and Beyond Foundation. So, first, our speaker for today is Mr. Abhinav Shingal, sir. He is a STEM catalyst, innovator, and he is here to speak on the topic STEM for everyday astronomy. So, without wasting any further time, we can begin, sir.
Okay, hi. Good evening, everyone. My name is Abhinav, and I will be taking a session today on. So I work in the field of STEM. I work with a lot of schools, teachers, kids across India. And my idea is that if we can just make STEM, the basic idea of science, technology, engineering, mathematics, a bit simpler in our life, space. Answer may be right, maybe wrong, whatever comes in your mind, please keep on sharing your answers. You can open your mic and speak, but let's have a very interactive session. Okay, so let's start. I'll just share my screen and okay, so I hope is my screen visible to all of you?
It is visible.
Okay, great. So we'll start with something very interesting, some unknown known facts of space and Earth. And we'll just try to see something which we see very obviously very every day, like sun, moon, all these things. Can we decode more about them? Can we see how beautifully we can find some theory, some logics of seeing them, understanding a lot more about things? Because in these 7 days there are a lot of people who have spoken last 3 days, and after me in next 3 days more people will speak. They'll talk much about science, citizen science, maybe asteroids, maybe a lot of planets and all those things. I thought I'll just speak about something which is very simple like sun, moon, and that is what I just want to start with today's session with. So I'll start with this interesting image. I came across a book in a school I went. It was a book of kindergarten students, and there was this interesting image of a night sky. Somebody has painted or maybe used a Photoshop to create this image. I'll just request you all, just watch this image carefully and tell me, is there anything wrong with this image? Can you find something which is a problem, something which is wrong, something which is logically incorrect in this image? So, I mean, you can just tell me, do you have any idea, anything you want to share, anything you feel that there is something wrong with this image?
Anyone, or you can just type your answer in the chat box.
Yeah, you can just, okay. The moon, great, Rosa. So can you just tell me the shape of the crescent moon in front of the moon? Okay, shape of the crescent moon in, okay, so, okay. Dashdi, again, he has written one more interesting thing. So there is, the problem is with the moon, okay? Can somebody just open their mic and tell me what's the problem with mic? Because it might be possible that what you are saying is absolutely correct. Okay, so Rosa has said the moon. I don't know. I mean, Rosa, you can just give more insight maybe. Dashti has said the shape of crescent moon and the stars in front of the moon. Great. So what I am able to know out of what you are saying, I'll just share again and I'll come back. There is something very interesting about this image. We see such image every time we see some kindergarten images, something on internet, everywhere. Somebody paint a night scene and they make some images which are like this, which are very interesting, very beautiful, but there is a big problem. The problem is the moon. If you just watch carefully this moon, around moon, in that whole circle, you will not be able to see stars ever, because a full moon, I mean a moon in night, is something like this. If you just watch carefully, there will be a black round circular patch which will not allow these stars, because moon is in front of us, stars are much beyond it, and the portion of moon we generally see is only the part which is illuminated, but the real moon is always there. So I'll just open Photoshop, and I'll just try to again show this interesting thing to you. Okay, so I hope you all can now see. Okay, you can see my Photoshop. Yes. So if you can see, this is how a moon normally looks like when it is a full moon. When it is not full, the moon stays there forever. It's just that some part of it is illuminated, because of which we see just that part. But the whole part of that circle is always there. The whole moon, the circular moon, the spherical moon is always there. We just see that portion which is not visible. I mean, which is reflecting light, but the rest of the portion is always there. So if it's very interesting, which this image in which you can just see that we are not able to see the whole moon, but this is how it is. And we just see, because it's common, it's the moon is always there. Okay, so we'll move to the next concept. Is the moon we see same everywhere across the earth? Again, I mean, I'll ask you all. So this is the moon. This is a picture of moon I have taken, and this is how moon looks like. But then again, can you all share your ideas? Is the moon same everywhere across the globe, or the shape of moon, the idea of moon changes at every place? The way we see moon, the way we look at moon, it changes. Okay, for the last question, Hari Shankar Nath has given a one more answer, which is very interesting. He says also the stars appears from the clouds. Yeah, that's fine. That's fine. But the most important thing was the moon. Yes. Okay. So we'll move to the next. Can anyone tell me, is the moon same everywhere? Because it's very
Hi.
interesting. Yeah. Hi, Rosa. Yeah.
So I'm at the Ecuador in Latin America, and I actually never see the moon that is shown in North American pictures. When I was a child, I didn't understood really why, because our moon from this latitude, the crest is always like vertical, like horizontal. Sorry,
Yes.
like a smile, something like that. So it
Perfect.
never shows like in the
Yeah, so
pictures.
great. So according to you, the moon is not same everywhere. Yes, okay. So MS Bala Kaushik has just said it's not same everywhere. But what changes, and why is that change? Why is it different? So what I'll do is I'll just try to show you something similar with the help of this interesting thing, globe. Okay. So if you watch carefully,
Because of the orientation of the
yeah, because of the orientation of the earth, correct. And it's very tough or simple to understand, but suppose this is a human being, okay, and if I place it like this out here, this person is right upright, but another person like this, who may be in southern hemisphere, will be standing like this. So according to the law of reflection, which we see, the light which comes from the moon, it will be vertically opposite for two people standing vertically opposite on globe, or on earth. But if you see these two people, they are not standing vertically. Yeah, they are at a different hemisphere, and they'll have a different idea of moon altogether. So it's a very interesting, again, a very interesting concept. So this is how we generally see moon, but because of this concept that, this is how we are upright at North Equator, and somebody in South Equator, or somebody who has, we just came across that somebody is not seeing the moon. It's because of this concept. So you see moon at different points, at different level. This moon and that moon are very different, and that is why North Hemisphere will find something like this, a moon like this, whereas a Southern Hemisphere will have moon something like this. So they are very different. The orientation is different, ideally, but yeah, we'll always see only the one side of moon. So if you'll watch carefully, you will see this spot out here, you will see this spot out here. It's the same side of the moon, but the orientation, the actual orientation is very different. And that is why, you'll find people, when you go to different places, you'll find people not getting connected with the moon, because the moon which you have been seeing since your childhood age. So because I stay in India, so in India, the moon which I have been seeing, once I went to Australia, I actually got very confused, because that was not the kind of moon, the full moon I was visiting, seeing every day. So it's a very interesting concept. And the most beautiful thing is that moon doesn't appear same everywhere. Okay, so we'll if there is anything to share or ask or say, you can always come in between and ask and raise your point. Okay, we'll move on to the another very interesting concept of moon. How far is moon as per you? So I'll just ask all of you. You can just let me know, how far is moon from us? The screen is shared.
No,
Okay.
so the screen is not visible.
Okay, so how far is the moon? That's the question. Now I think it's shared.
Yes, sir.
Yes. So can you tell me how far is the moon? Anybody? So it's approximately 3,84,000 kilometers. The dia of our Earth is somewhere around 12,400, or 700. The radius is somewhere around 6,400, 6,300. It varies at poles. So poles have lesser, diameter. The equator has a bigger diameter. But in relative terms, can you just tell me how far, how big, or how much distance is there? Because, if you'll just remember our textbooks, we used to see something like this. So I'll again show, this is our Earth, and this is the moon. And they're almost exactly like this, only ratio. So their ratio is almost similar. This is approximately, this whole Earth is approximately what, 12 inches or 30 centimeter. This is approximately 8 centimeter. The dia. It's almost similar, but can you just tell me how far they are? Because since my childhood, I have always seen in my school books this, and a sun all together in single frame. So with your understanding, can you just tell me how far this small moon is from us? So suppose I take Earth to be this big. Can you tell me how far would have been this from our Earth? Any idea? Anyone who want to share can just tell me, how far is moon from us if the Earth is this big? This big means it's approximately 12 inches or 30 centimeter. And this moon is approximately 8 centimeter in diameter. So can you just tell me how far is? And I'll just show you something which I worked upon, this afternoon. Just try to figure out correct proportion and just to understand how far it is. So anyone who want to tell me how far is it? Okay, I'll just share with you. See. So this is what I did in the afternoon. I took my globe on terrace. I took my moon on terrace. And then I just thought, let me bring them in proportion. So I placed them this close. Do you think they are this close? Because that is what we have been studying in our textbooks. Do you think they are this close? Anyone?
No.
Okay. So how far? I'll just put, so this, they are far away from this. You can just see the image. This is Earth, this is moon. They are a bit far. They are approximately 700 centimeters, 70 centimeters, or approximately 7.7 a meter away. Do you think this is right? No, this is not right. Do you think this is right with the same size of Earth and moon? 2.5 meter. Do you think it's right? No, it's not even this close. Do you think this is right? It's 5 meter now. Okay. Can you see Earth, Moon, how far they are from each other? Do you think it is right? No, it is not even 5
No, no.
meters. Can you
It's
see
still
this?
beyond.
Yeah, it is 6.8 meters now. Do you think it is this far? It's very far. You can just see how small it is in front of the whole image. But do you think it is right? No, it is not even this far. This is 8 meters. My terrace ended with this 8 meter. I cannot go beyond. But the real moon is almost 9 meters from this globe. So if I'll take this moon more a meter away, that is how far the moon is from us. For years we always think that moon is close. We know the distance, the mathematical equation, the number we always have, but in terms of proportion, that's the biggest interesting thing. The moon is this far. So suppose this, and now just think this moon to be this small. This is so small, and now think what all possible things you can see. So even if I take this earth around anywhere, I will always see moon in that direction. Now on this earth, which is this big, we humans are hardly, we are not even equal to a coin on this. So we are not even equal to the finger imprints as compared to this globe. Can you see the globe in my hand?
Yes, sir.
Okay, so we are not even equal to the finger imprint on this globe, and this is how far the moon is from us if you'll compare. So this is the reason why there are not eclipse every 27 29 days, although we have a full moon or new moon every 29 days. This is the reason. There are reasons that the tilt of moon is there. The axis is also tilted at 5 degree, but it is very far, and that is the reason we are not able to have so many concepts of moon in our daily life so easily, because we are not able to understand the distance of earth to moon very easily. So it's very interesting that once you understand how far the moon is, you'll start understanding the proportion. Because if moon is this far, can you tell me how far will be Mars from the same globe? So again, that's very interesting. But anyone who can tell me, so how far will be Mars? Because then again, you'll just get an idea that how lonely, how alone we are in the whole space, how far we are from everything. Because when I'll say it's 1 light year away, we'll say, okay, great, 1 light year away, maybe some unit, but we don't understand the distance in the practical ratios. So if I'll say how far will be Mars, if this is the globe, is Earth, that's the moon, small. The size of Mars will obviously be more than the moon, but how far? Any idea? So Mars will be approximately not less than a kilometer away from this small globe. So can you imagine, a kilometer away there is a small ball which is rotating around the same sun, around which we are also rotating. And it is, it's such an interesting thing that we are revoluting around sun, the Mars is revoluting, but the distance between us is almost a kilometer if we take this ratios. And that gives you an idea that how huge, how big is our whole solar system is. And we have just reached to Mars, we have just discussed Mars. Beyond Mars, there is, on one side we'll find Venus, and then Mercury, and the other side we'll go Jupiter and a lot of these things. So it's very far. We are very away from all these planets. And if we'll just get deep into it, we'll start understanding the depth of these planets and everything. Okay, so time for some very interesting illusions. I'll just request you all to watch carefully. Whatever comes in your mind, tell me that answer. Don't tell me the answer which comes in your mind afterwards, because after an illusion you'll start understanding what is the illusion all about. So I'll just request you to make sure that whatever comes in your mind, you tell me those answers. So I'll just stop sharing once again, and I'll again take you to my Photoshop window, and I'll share my Photoshop window now, and I hope you can see. Okay, so I'll come up with the first illusion. Please, it's my request, if you know the answer, if answer comes in your mind, please tell me what's the right answer. So there are few illusions. Tell me which circle, orange circle, is bigger, the A or B. You can quickly type your answers in the comment box. Please be a part of this. Tell me which circular disc, the circle, is bigger, the B or A. Okay, so there are few people who are saying A. I'm not asking about the gray one. I'm asking about the orange circle. Which is bigger, the B or A? So B or A, quickly tell me. Yeah, they are same. Rosa is saying, but I can guarantee it is not looking same. You know, you can, because it's a very simple. You will always think there might be some catch, but yes, it will always appear the B to be bigger. I'll come back to my Photoshop screen. Just watch carefully. So I'll take this and I'll move this. Okay, and I'll place them on each other. See, they're exactly same. It's just an illusion because of the background around it. Okay, next one. This time please be very serious. Tell me your answer. Whatever is the answer, please tell me which rocket is bigger, the B or A. Please don't think, just tell me what you are seeing. I don't want the answers which are logical. I want something which is visually, in front of you. So whatever you are seeing, start telling me which rocket is bigger. I'll just wait for 10 seconds more, and then we'll say, so we'll just see which rocket is bigger. A is bigger or B is bigger. Tell me which rocket is bigger. Okay, so now, yeah, so Mr. Bala Kaushik is saying that they both are same. Great, they both are same. Now everybody will say they both are same because you have started to understand it's an illusion. Okay, now I'll come back again to my image and I'll ask you last time, which is bigger, A or B? I can guarantee if I'll ask you straight away, you'll always say B. But let's do some Photoshop, okay, and bring the rocket A close to rocket B. There he goes, and see, they are exactly on same. They are exactly same. Again, it's just an illusion. Okay, the last one. Just tell me which line is bigger, the vertical line, which is V, or the horizontal line, which is H. So V is the standing line, H is the sleeping line. Please tell me which one is longer. Yeah, great, Bharti. So you are saying V. It's absolutely a correct answer. You don't have option. V is the answer because that is what you are seeing. Dashni is again saying that it's V. Great. That's again what is being visibly. We can see. Sunanda is now saying they both are equal, but I can guarantee, Sunanda, if I would have asked you the first time, you would have always said V. Okay, great. So great. I'll come back to the last thing. Just watch this carefully. I'll select this, Control T, I'll rotate it, and 90-degree, enter, and I'll bring them close. See, they are exactly same. So the point is that sometimes what is being shown to us is not the right answer. I'll come back to my presentation. I'll just again share it, and yeah, so here comes the presentation. Okay, so you all gave me different answers, and this comes why I asked you all this, because there was something very interesting which is coming up. So you all see that there is a huge amount of illusion around us of things we see that same illusion every day in morning, every day in evening, every day in morning again when we see moon, and every night when we see the moon setting. The interesting thing is, just watch carefully the moon. Look how big it looks, right? See this sun, how big it looks like when it's rising in the morning. See this moon on some super moon or normal moon day. Look how big it is looking like. See this sun along with this images of buildings, and you'll see how big the sun is. See this around the sun again, you'll say how big is the sun. Why do sun and moon appear big during the sunsets or the sunrise or moonset and moonrise? This is what I wanted to show you. We have always been talking about this. any day, tomorrow, please try, get up early, see moon rising, or try it out. If you're not interested to get up early, maybe wait till the evening, see the sun setting. You will find sun very big when it is setting and rising. But it is setting and rising, it has nothing to do with the size. It is just an illusion, because what happens, it is something like similar to what we have seen in those images. What happens is that something like this, if I'll just bring this image again, maybe this. So what is happening is the sun is exactly of the same size. There is not at all even a single iota of change with the size of the sun. What is happening now is, instead of the whole vast sky which is there above us, we'll start seeing something along with this, this sun. So in this case, we are seeing some mountains, some buildings, and when we have these as a reference point, something in between them will look of different size. It might look bigger, it might look smaller, but because sun is very big in the whole structure, it starts looking very big when it is setting or rising. And it is a very interesting thing. Anytime, any day, anytime, whenever you will see a sunrise or sunset, it will look very different. That is the reason people go to different places just to observe sunset, because it is not the sunset or the sunrise which they are going, it is in reference to something. So if you are around a sea, when you see the sun coming out of sea, from the horizon, you will find it very big, because you have a reference of sea in front of you. If you'll ever get a chance, go to a mountain, or you have been to a mountains, you will see that behind a mountain, the sun will look amazing. And when it is coming out, it will look very huge. The same thing happens with something like a moon. So when moon is setting up, coming up, it looks very different, but it is always same. A new moon will always remain a new moon. A super moon will always remain a super moon. The difference of the size is very less. A super moon and a normal full moon, the size difference is just 8 to 10%. So you will not be able to identify. What matters is the reference. So whenever we'll have something in reference, you will always see. So please remember, it's a very interesting thing. Anytime, any day, sunrise, sunset, the moon or sun will always appear big, but it has nothing to do with any other thing, any other phenomena. It's just a reference. In fact, I'll share very interesting thing with you. With moon, there are some days when moon is very close to us. Okay. Those days when there is a moon, a full moon, and the moon is very close to us, we call it a super moon. But can someone tell me what is a blue moon? Because sometimes we have a super blue moon and people goes crazy that now, it is a very rare thing. It's super blue moon. Can someone tell me what is a blue moon? Super moon is when moon is closer. So suppose this is moon every day on a full moon. If you'll just see this big, it will become a super moon. So this is a normal moon. Watch carefully, huh? This is a normal moon. This is a super moon. Just a little bit difference. But can someone tell me what is the color of moon on a blue moon day? So we all talk about blue moon. But can anyone tell me what is the blue moon all about? What is the blue moon? I have tried this, taking photos. Okay, great. So Bharti has just said that she has tried, maybe, or he has tried to take the photographs along with some reference, and they've been able to take things in a different perspective. Yeah, it's an illusion. But can someone quickly tell me what is a blue moon? It's a very interesting concept. But can someone tell me what is blue moon? What's the color of moon on a blue moon day? So anyone who can tell me what's the color of moon on a blue moon day? Okay, so maybe I'll just tell you quickly. So blue moon, yeah, Mr. Bala, you were saying something? Okay, so
it was blue color, I think.
It's in blue color. Okay, so yeah, blue. Bharti is saying again, it's blue. Again, it's a big myth. There is nothing related to blue on a blue moon. So due to atmosphere, what Gautam is saying, blue moon has nothing to do with blue color of the moon. I'll tell you, it is again very interesting, because for years we have been told that it's a great sight, it's a blue moon today, and we start and see a full moon, go out, see moon, and we say, "Arey, it's looking amazing, it's looking big, it's looking blue, it's looking there." There is not even a single difference between a normal full moon and a blue moon. Blue moon is not a scientific term. It is an English term. It's a language term. So what happens is, every 29 days we'll have a full moon. So suppose on 5th we have a full moon. Most probably on next month's 24th we'll have a full moon again, considering the month is for 30 days. Okay. Now, if you just try to understand, blue moon is when we'll have 2 full moons in a single month. And it's such an interesting thing that for years we have been told, there are so many newspapers, there are so many news channels, there are these apps, or there are these influencer pages which tell you it's a superb sight this week, because you'll see a blue moon on this date, and we all go out and see the moon thinking that it's something different. Blue moon has nothing to do with anything to do with color. Blue moon has nothing to do with atmosphere. In fact, there is nothing to do with science. Blue moon is just an English term. When we have 2 full moons in a month, the second full moon is called a blue moon. And that's why we have been listening to an interesting term which we use, once in a blue moon, and that comes from the same point, that the blue moon only happens at that time when we have 2 full moon in a same month. So it is not a scientific term. It is just a very simple English term, and we just keep on getting influenced by it. So we'll come back to something which is more interesting. This you must have seen this. I'll just show you one single small this video. Please tell me, other than the size of moon, can you notice something which is more interesting? Anything with this image? So I just showed you a video of sun setting, and there is this image or video of sun rising. Other than the size of moon, can you see something more interesting? Okay, so Bharti have asked about red moon. Bharti, I'll come back to that red moon in the end, but we'll just go to the next. Okay, but yes, so can you just tell me something interesting which you have just noticed? Okay, so I'll just share. It's why do sun and sky appear red in morning and evening? Again, a very interesting thing, that for years we have been seeing that moon, the sun, early morning the sun appears red, and as it goes up it changes its colors. The sky also changes its color. So early morning it's amazingly red, very dark red, and then gradually it turns into blue. So the color of this sky or sun has to do with something very interesting. Can someone tell me anything which you feel comfortable with? You, whatever comes in your mind, you can tell me. So we have been getting a lot of answers. I'm very thankful that you all have been constantly helping me out to make this session more simpler and interactive. Can you just tell me what happens, that why do we see sun? Okay, so MS Bhatt is saying scattering, dispersion of light, great sunlight has to travel longer distance, no longer wavelength reaches. Okay, Bharti is saying absolutely right. Great. So you all are saying whatever you are saying, it's perfectly right. I'll just show you what happens. So it's again an interesting concept. See red. See this. It is not red in this image. It has just turned into yellow, or maybe somewhere around yellow orange. Okay. And I'll come back to this. Watch carefully the color, around the sun. Just watch the color. It's yellowish orange, and just see how it converts. It changes into red. And great, done. So what is happening out here is, yes, this is a very interesting phenomena which we can always try out with maybe just a soap bubble. Put some light on it in soap bubble on a sunny day, you will see the scattering of light. Rainbow again, but rainbow we don't get chance to see nowadays very easily. But maybe if you are able to see rainbow, again you will see the same dispersion of light. And what happens is, light is made of 7 colors. It disperses as it goes through a medium. This exactly happens in a glass prism. This exactly happens because of our atmosphere. So if our atmosphere won't be there, a sunrise and sunset will always be of single color. So if you are there on moon and you will see a sunset or a sunrise, there will be a no red color of sun. You will always see a single color moon throughout the day because there is no atmosphere. But because we have atmosphere, this is what happens. So on a normal day, I'll just try to draw something. Okay, so I don't know. I just sorry, just a second. Okay, are you able to see all?
Yes, sir. It is visible.
Yes.
Okay, thanks. So I'll just use my pointer and I'll highlight. Okay, so this happened on a normal day when it's daytime. The sunlights are coming like this, considering the sun is vertically above us and there is very less space of atmosphere through which it goes. So the light is not able to disperse huge, and that is why we are not able to see the color as this. But what happens on any other day when it is, during the evening or the morning time, the sunlight comes like this. It enters the biggest portion again because it's sideways, so it enters the biggest size of atmosphere as compared to earth, and then it diffuses. And because of this diffusion, there are different colors which comes out, the red being the highest in terms of the wavelength, will come and glow the whole atmosphere around us. So red is the color which comes out, and it's a very interesting phenomena because we study light dispersion forever, but this light dispersion which is happening because of our atmosphere, we generally don't notice. But when we teach in our schools, we always tell them prism and all those things, but the biggest prism around us is our atmosphere, which gives this kind of impact. I just want to know, with you all, that can you just tell me that if ever if we are there on Venus, what will happen on Venus? Will we have a different color of the morning or the evening, or will it be same on Venus? So any idea on Venus? Okay, different. Yes. So it will be exactly same like us. On Venus, again, they have a huge coating, a huge layer of carbon dioxide, a lot of gases. They'll have different colors in the morning and evening. Okay. Whereas on Mercury, we will not have any much difference because Mercury, Moon, they don't have even a thinnest layer of atmosphere around them. Great. So we'll move on to the next concept, but thanks for being part of this till now. Okay. So in India, we have a lot of different kind of places from where we launch rockets. In India, we launch it from a very interesting place called Sriharikota. It's a place in the southern part of India. I just took this as a part of my theory or my idea that we debunk why a space station, a space launching pad is made at some or the other very peculiar point. It is not everywhere. There are a lot of interesting things. So I'll just start. This is half of the India. The other half is at top of it, which we cannot see in this image. But this is the southern part of the India. And you will see this place. It's called Satish Dhawan Space Center, or the place is called Sriharikota, which is here. It's again a very interesting place. This place is they're almost every 15 days, 20 days, 30 days, we launch something or other from this place. Can you just tell me why? And this is how it looks like when we do a lot of close-ups. So there is a small lake here, a lot of in-waters, backwaters which have come. This place is here, and then there is on the right side, there is a sea. Can you just tell me with your ideas, why do we launch it from this place?
Because if you launch rocket from there,
Yes.
the Earth's rotation will help in uh, with the rotation of the Earth when it's orbiting the Earth, when the rocket.
Okay, so Earth's rotation will help. Okay, but any idea why Earth's rotation will help? Why will Earth help? What is the logic? Okay, so I'll tell you, there is something very interesting which is happening. Can you tell me which way the sun rises every morning? It's a very common question, but can you tell me which direction the sun rises every morning?
East.
East. So again, so it's again a very interesting thing. We have always been told that, you know, the sun rises from east, but there is some problem with this theory. You know, the problem is that the sun doesn't rise from east. We are rotating on our axis from west to east. Yes, so Bharti is saying absolutely correct. So we are rotating from west to east. I'm sure you all must be knowing this. We rotate from west to east. And if I'll just show you this globe again on screen, you can see. So maybe at present what you are able to see is some part of Japan in front of you. And when you will just watch carefully this part of Japan, and then I'll rotate it like this, and a new part, you can see Australia at the bottom, and some part of China, and then India, and it goes forward, and then the Africa will come up, great, and above that Europe, and then we'll see, and this is how the earth is rotating. So it's rotating like this every morning, every night, every time it's rotating like this. It's a very interesting concept. It is rotating from west to east, because of which, yes, yeah, absolutely. You know, what Apollina is saying, it's correct, that what we feel, you know, is what we say, right? I mean, that is why we say it's. I'm not saying it is wrong that sun rises from east. I'm just telling you the sun doesn't never rises. It's we who are rotating around it and revoluting, which makes us see the sun. But that's this motion of Earth, which is from west to east, is the most interesting thing. You know, because of this motion from west to east, out of a lot of interesting things, there is a very interesting thing which comes up, and this is called a centrifugal force. Centrifugal force is whenever we rotate, you know, you can always try it out. Hold maybe a ball, tie it with a rope, and just start rotating it. Once you start rotating it, you will feel that that ball wants to go out. If you leave, it will go flying away. And to make you understand much better, I have this video. So just watch this video. It's a hammer throw video.
Bowser has been real quiet since this guy started showing up.
Okay. So I seriously never understood what they said in the at the end of the video, but the idea was that, you know, if you'll just see, this earth is rotating at a very high speed. Okay, we don't feel because we have been born with that rotation. We have, since the day we have born, we are there. But earth rotate at a very high speed. On equators, you know, the speed is very high. As we go up towards the pole, the speed reduces. The speed which I am saying is the relative speed. I am not saying the speed of earth slows down, the relative speed. So any place, the speed will be how much distance a point will cover. So equator being the longest circle on this sphere will have the longest distance. At poles, the distance will be very less, but the earth is rotating at its own pace. You know, if you'll just see. So what happens is that as the earth rotates, the point, you know, if you launch a rocket, it will always, if it's easy to go towards west, you know, sorry, towards the east every time when we launch a rocket. And that's the reason why whenever you will see any rocket launch happening across the world, not India, any place, you'll always find that it is happening on the eastern side of that country, because with the eastern side it becomes easy to make use of this centrifugal force. And how does this matter? I'll just show you with a simple experiment which we did today. There's this globe, and I just stuck a small piece of paper on this. You have to watch very carefully, but just see a small piece of paper flying away. Okay, I'll just play. Okay, so as we rotate it, you can see, okay, great. So you can see a paper flying away from the earth. And this paper is able to fly because of centrifugal force. there is not even a single booster in this, in this paper ball which we have made. There is no fuel, nothing. It is just that small piece of paper, ball of paper. But because of the centrifugal force, the paper tends to move out, and once it tends to move out, it becomes very easy for that paper to fly away. So what we do is, it happens every time. I'll just show you again with the help of image, and if you'll just see, watch carefully this part. So just a second, I'll just move on to the editing part. Okay, so now I'll just show you with a pointer. Okay, so what happens is, ideally the equator is like this as compared to India. Okay, now the rocket wants to go up in sky, but because of centrifugal force, it becomes easy to launch this rocket, because the centrifugal force helps the rocket with an extra thrust, and this thrust help us for to save fuel. And that's a very important thing, because to take rockets into higher trajectory, we need more fuel. Either we reduce the weight of the rocket, but to reduce the weight of the rocket, we need to put less fuel, and less fuel means, again, the amount of distance it can travel will always be reduced. So what we do is, we generally tend to launch it from the eastern side of any country, so that it becomes easy for that rocket to go into trajectory. That's one. There is something more interesting. Okay, as you have said, it's closer to sea. So all this is sea, and if the rocket, in case of any problem, goes haywire, it can always fall in this huge land area, I mean this water area, and that can be a big problem, or a big calamity can be saved. So this is the one very interesting thing, the centrifugal force. I'll just tell you one more interesting thing. So safety is again an interesting thing which we have talked. This is a all ocean or sea out here. In India, we call it Bay of Bengal, and it's route right here, and it's a huge sea. So anything flying out here will go like this. But sometimes we want to launch a simple, smaller satellites, simple, smaller rockets, which don't have much weight, and we want to put them in a polar orbit. I mean, equatorial polar orbit. And this polar orbit goes something like this on equator. Now it becomes tough for this to be launched from here till this point. So what we generally do is, when it is lighter, we generally go like this from India when they are launched. Okay, now when they go like this, it creates a lot of problem, lot of risk possibilities, because it's flying on this small part of land, a small island around India. You can just watch carefully this, and I'll just mark it with a color. Okay, so this portion is always on risk, because the rocket is not a very heavy satellite. It's not a very heavy rocket. So what happens, that instead of giving it too much time of going into sky on this side, we generally tend to send it straight into the polar orbit, which is right on equator. And what happens is that we cross this portion of the near to India, which is Sri Lanka. So what happened recently, it's again a very interesting place, that India has again made a new launching pad, which they will be coming soon, very soon. It's in a place called Kulaseka Paramatyam. I'm not able to pronounce that word, but yes, it's on the right tip of India out here, if you'll see, at this point. And it makes it easy for the polar satellites to go, because from Sriharikota, this will always create a problem, because it's very close to Sri Lanka. But if we'll go on this side, it becomes easy for rockets to be launched on this side. So that's again a very interesting thing. We have been seeing. And then so these were the few things which I wanted to discuss with all of you. I'll just open my session now for any kind of question, answers, anything which you want to share, anything which is different, but you can just let me know if you have any doubts, anything to share, anything you want to ask.
You can feel free to type in the chat box, or you can directly switch
Yeah,
on your
you can
mics
type.
and ask the question.
Okay, Bharti has asked, does it help in paragliding also? Bharti, it might help in paragliding, but the only problem is the amount of force which we generate at the time of paragliding is very less as compared to our mass, one, because the mass of somebody paragliding is very less. Second, there is always a huge amount of thrust which is being generated on a paraglider. So what happens on a paraglider? The paraglider is like this. There are two forces. It's similar to what we see in planes. You know, the force of the vertical force pushes it from bottom like this. This is what we call the upthrust. The weight wants to go down, which is we call the drag. And it's something very interesting in anything. So if you remember, when we used to make paper planes, the paper planes are like this, you know, the wing, the downward things, it is you know, it applies force, which is because of air friction. The upper one push it down because of our weight, and it sails. But in case of rocket, there is no point of drag or thrust. It's just go vertical. In fact, just to come out of the drag, which is of air, you know, air friction, there are these you know, what do we call them at the bottom? So um, so we put these fins. Yeah, so we put fins, or maybe we nowadays have, you know, the boosters which automatically change direction. So it's very interesting. But yeah, so paragliding, we don't have we don't have much you know, role of this direction. But yes, for rockets, it's something which is very important, very interesting. Okay, is there anything else you want to ask? Can you repeat the thing of polar satellite? Okay, so Bharti wants to know more about polar satellite. What happens, Bharti, is I'll bring it like this. Okay, so you can again see Earth like this. Okay, yeah. So Bala Kaushik, what you are saying is absolutely correct. We have gimbal engines, but for somebody to understand a gimbal engine is very tough, because you know, we have not been able to understand. If you ask any kid even today to make a rocket, they will always add fins. So you know, I always tell them that fins are something very interesting. It helps to bring the center of mass downwards, because of which a rocket goes through the air very swiftly. So gimbal engines are great. It's one of the most amazing innovations. But if you'll always think of a rocket, a fin will always come to your mind. So that is why I was giving you the example of fin. I'll just show you interesting thing on this Earth. You know, at this point, you know, if a rocket goes out, something like, okay, I'll just take a small pen cap. I'll just put it like this. If a rocket goes out, the idea of this rocket, if it is into it needs to go into the geostationary satellite. The idea is to go as close to equator as possible, because that's the only point where it can maintain a fixed point of orbit around the Earth. Okay, now what happens is, as we go from different positions, the idea is to go as close to equator. So what India has done recently is they have tried to build up a new you know, a new space launch station, which will be right at the bottom of the country, so that the distance from equator is reduced as much as possible. People staying in Europe, and if you want to launch your rocket from Europe, or the ESA, which is launching, or other space stations, space agencies which are launching, they have different issues. India had some other issues which was related to all the geostationary satellites which needs to go close to pole as soon as possible, or sorry, equator. And they being smaller in size, there is always a constraint of fuel. So if you have a big rocket, something like Chandrayaan, they will always go from Sriharikota, because they need big boosters, huge amount of fuel, and you have fuel to take it along this line, you know, away from Sri Lanka. But if you have a smaller rocket, you always tend to go straight, because that's the shortest path, and you always want to take the shortest path. And in that case, there might be a possibility that you, in case of any problem, you might fall in Sri Lanka or nearby areas. So we, you know, India is making a new space launch station, but it will be only used for satellites, rockets, which are very small in the total mass of that the satellite. Yeah, Gautam Shiv Kumar, you are saying absolutely correct. It is coming up in Tamil Nadu, which is very close to the tip of India. How gravity works on rocket? Okay, Manik is asking how gravity works on rocket. Manik, it's amazing concept of rocket. Rocket is constantly being pulled downwards because of our gravity. In fact, I am writing a very interesting paper. We'll share some other day. You can always, find me on LinkedIn or all these places where I keep on doing a lot of research. I work with a lot of kids across India, and I'll tell you, gravity is such a complicated topic because it becomes tough for kids to understand that what is the role of gravity, because we make it very simple. Anything falling down is gravity, is what we tell. But for a rocket, the gravity, the logic of gravity, the axis, the turn, the curve of earth, they all are important things. So how gravity works on rocket? Gravity non-stop works on gravity, on a rocket till it reaches a point. This point is the point from after which it will not experience gravity anymore. Okay, till this point the rocket needs to go at a very specific speed. We call it escape velocity, a velocity at which it will escape the earth. But that escape velocity needs to be accelerated for a constant time. So whenever I ask a lot of people, they always say that, what is the speed at which I need to go, I need to fly, or I need to be fired so that I go out of space, and they come up with the answer of escape velocity, which is some velocity at which but we just forget a very interesting concept of acceleration. So it's something like, I can be at 100, if you'll drive a car, you will put your feet on accelerator. The more you will accelerate, the faster your speed will go up. A difference between a normal, very simple car and something like a Lamborghini is that they both might reach 100 kilometers per hour speed, but what is the time duration they'll take? Okay, so more is the time, less is the acceleration. Now, with gravity there is a very interesting concept. So we feel that escape velocity is the velocity which is required to fly out of earth. It is not the escape velocity, it is escape velocity for that constant time which will make you fly out of earth. So if you shoot a bullet, it might cross that escape velocity, but it will not go because that acceleration is not there. The velocity is only for some time, and then as it goes up, the velocity will keep on reducing, and after a point it will become zero, and then it will start falling. So gravity has a very interesting role on any rocket which flies. And it's very great that the point of today's session which I wanted to make is that we look at a lot of things. In fact, for last 3 days I have seen a lot of sessions. In next 3 days also I'll see a lot of sessions. Whenever we talk about space, we generally talk about exoplanets, something like maybe dark matter, or the other day somebody was talking about black hole and all those things. We generally not look at things which are very simple. If you just start seeing moon again from today, you'll start feeling there is so much to learn from moon, because there is an interesting concept. I'll just tell you one more interesting concept. So sunrise and sunset happens every day almost on the same time, plus minus a minute. So suppose today the moon sunrise was at 6 o'clock in the morning. Tomorrow it might happen at 5:59 or 6:01. But can someone tell me what's the difference of time between moon rise every day? So suppose moon rise was today at 7 in the evening. What will be the time tomorrow? Any idea? Anyone who can tell me what time the moon will rise tomorrow? Okay, so I'll tell you, moon will rise at least 40, 45, 50, 30, 38, 39, 52, 55 hour late from today's time. So if it was 7 in the morning today, yeah, Sunanda, so 45 minutes is the correct approximation. It's 50, 55 minutes every day. And every day it comes 55 minutes late. So suppose today it rises at 7 in the morning. After 12 days or 10 days, something interesting happens. The moon rises in the morning along with sun. It sets almost along with sun in the evening. And in night, you will not see a moon. And you will try to tell some kid or someone around you, oh, I cannot see moon. It might be a new moon, but it is not a new moon. The moon has been in the orbit only throughout the day, and in the night it has already set. So it's a very interesting thing. But we can just think more about this. If there is more questions, you can ask me. But my point is, just try to bring small concepts on these things. Sunanda is saying tide depends on it. Tides do depends on moon, but again, that's again a very interesting myth that tides only depend on moon. Tide depends on moon and sun both. On when so if this is Earth, this is moon, and this side is sun, tides will be best at this time and on the other side. Because what happens on a tide day, you can just try. So you can take, okay, I have this cloth. If you just stretch it like this is the kind of pull it generates. So pull is on the both side. Tides are on the both side, on this side also and on this side also. On top and bottom, the tides are very less, and that happens throughout the day, right? So yes, tide depends on this. Bharti Kaushik is saying, so is that true that satellite orbiting Earth are free fall motion? Okay, so Bharti is asking a very interesting question. It's in free fall. Yes, they are always in free fall, but that doesn't mean that they'll fall on Earth. I'll make it very simple for you to understand. Just think this moon. Can you see this curve? Now, what happens in the projectile motion? The moon wants to fall. Whenever it falls, it finds a curve, and as it finds curves, it wants to fall more. Moon doesn't know that it is falling, but yes, it is falling. But because of the curve, the moon or any satellite around which is going around Earth keeps on falling, but it is not falling. Free falling means it is not falling towards Earth, it is falling vertical, but because of the gravity is pulled a bit towards any planet or any object. Like that is what is happening with sun. We all are following the same rule, that because of that projectile motion, we want to fly away because of centrifugal force, but gravity wants to pull us down. And while falling down, every time we fall, the curve takes, and moon takes that curve, and we keep on, the Earth takes that curve, and we keep on falling on that whole curve, and it keeps on happening every time. Okay, so any other question? Anything you want more to? Anything more you want to ask? Okay, so I'll just finish with one interesting thing. You need to look at things which are beyond what we generally see. We find things very simple. We have Ashray with us, who have been constantly being with us throughout this session. Thank you, Ashray. But I'll just give you a very interesting example before I finish. We need to look at things beyond what we see naturally. Something which is evident in front of us might not be right, or there is something beyond it. Okay, for example, suppose Ashay, you are wearing okay, so I'll just ask you something interesting. If I'll cut these ear of Ashay, okay, what will happen? Can someone tell me what will happen? So if I'll just cut them like this, like this, what will happen to Ashay? Can someone tell me? It's a very interesting thing. It's all about observation. Can you tell me?
He'll cry.
He'll cry? Okay, that's most obvious answer. Yes, he'll cry. Anything more you'll think will happen? One is he'll cry.
We cannot see his
Okay, so Bharti is now saying blood. Yes, there is one which will listen blood. But
not listen perfectly. Not listen perfectly. No, he will listen, because we don't hear because of this. We hear from inside. The eardrum is inside. You know what will happen? Ashray, can you come on screen once again?
Yes, sir.
Okay, so watch carefully. If I'll cut these ear for Ashray, he will go blind, because he will not be able to put his specs here. The point is, you need to look beyond up to what we are seeing, because generally we just observe and we are ready with an answer or a theory. But my point of today's session was, let's try to become more observant. Think of things which are around us, moon, simple stars. And okay, so Bala Kaushik is saying we are not able to understand. Bala Kaushik, he puts his specs like this, and the specs, the sticks goes here. If there is nothing like this, where will he put his specs sticks? And if I'll cut this, he will go blind.
I would see blur, but I won't see blind.
I wanted to say that
Yes, yes.
I wanted to say, if we cut the ears, we cannot walk, we cannot stand, because the ear contains the it stabilizes the body, right? That's why.
Yeah, obviously, but that those are all technical, high-level questions. My point was
Yes,
just
yes.
look at things which are very simple
Yeah.
in life, and with this space also, just try to make sure that double tape perspects. Yes. I know you will come up with all the kind of answers. My point is just try to look at things which are very simple, because once you look at things which are simple, you will start observing things. People who have not been on mobiles, have never been on screens, lot of these things for years. Just think 2000 years ago, 1000 years ago, somebody sitting in a jungle just looking at stars was able to understand so many phenomena of stars, moons, just by observing. So to become a better space enthusiast, start observing more. That's the whole idea of today's session. Talk about smaller things, talk about small things, learn more small things, because that is how we'll become bigger in terms of our knowledge. Find anything more you want to ask, you can ask me. Yeah, thank you, Apollonia. Thanks, Apollonia. Yeah, and anything more, we can always, and we can always stay connected. You can always find me on LinkedIn. You can always ping me through Hex-Star Universe and all the organizations which have done this. I'm really thankful to all of you for giving me a chance to speak. Keep experimenting, try out things on your own, and you don't need big infrastructure to actually experiment. This small moon is just a smiley ball on which I have wrapped up a tissue paper with some Fevicol glue. So it's you don't need much of infrastructure to try out things. It becomes very simple for you to try out things with the things which are all around you. Ashra, is there anything more, or we can finish?
Sir. We can finish. So thank you so much for it. It was a wonderful session, I would say. Every example you gave me, it was great session. Thank you so much, sir.
Thank you.
I would again like to thank the organizing members, or the organizing organizations, Hex-Star Universe, along with SSC Business Science Group, and Life, Work, and Beyond. Thank you so much again. And I would like you all to stay connected for 3 more sessions. More such wonderful sessions are going to come ahead. Thank you so much.
Thank you. Thanks a lot.
Thank
See
you
you
again,
all.
sir.
Bye someday. Keep
Thank you.
experimenting.
Bye.
Yeah, you are saying something? Okay. Okay. Great. Thanks a lot. Thank you. See you all someday for sure. Thank you. Bye.
Thank you so much.
Thank you.